Awesome. Great, thank you so much. All right, welcome everyone to the Open Wallet Foundation Wallet Interoperability Special Interest Group call for October 6th, 2025. Today on the agenda, we will hear about the Digital Credentials API from Tim Cappalli of Okta. So thanks again for joining us. We are recording this call. It will be posted on the meeting page later today. We are, of course, following the Linux Foundation antitrust policy and the Open Wallet Foundation Code of Conduct. Let's see, are there any announcements or introductions before we get started? If you're joining the call for the first time and would like to introduce yourself, feel free to hop off mute and share about what you're interested in or working on in the space. Let's see, I know we have
Go
ahead.
Yeah, I could just say that David Margord, who is leading the WeBuild work in Europe, he promised to be here at our last meeting in November. I think that's going to be very interesting to hear how this work, especially with the business wallets, is proceeding. So and what kind of interoperability support he would like to have from over the big water.
Mm-hmm. Absolutely, that's great to hear. I'm looking forward to having him join us as well.
You just need to send him the invitation with the technicalities, and he's actually expecting it. So if it can be done soon, that will be fine. Thanks.
Yes, absolutely. Let's see, Stephen, you have your hand up.
Yeah, an announcement that DIF last week completed their process for recommendation of the did WebVH method. So did method. So this is so there's dids can be registered, which is a very easy process at the W3C, but DIF has created a more substantive process where they go through the spec in detail as a group, provide a sequence of events that occur, and did WebVH has gone through all of those processes and steps, presented multiple times at DIF, and the PR for did WebVH to become recommended has been open for the 60-day period required. No objections were raised, and good feedback was received, and the spec updated accordingly. And so as of last week, did WebVH is the first of several to come, but the first DIF recommended did method.
Awesome. That is great to hear. Thank you for reporting on that. That's yeah, that's exciting to hear. What do you think are the next ones that are coming in that process?
I know that did Web Plus and did Checked have started the process. So they're the furthest along, and then there's a few others that are there and following up.
Okay, awesome. Great. Let's see. Thanks for those announcements. We also have IAW coming up, as well as the Agentic Internet Workshop the day after, as well as, I believe, a developer summit virtual around IAW. Are there any other announcements that anybody has? All right, let's see. In terms of project updates, I know for Cappalli, the Canon PR is getting really close. There's the new name and logo that's being discussed as well. RC 1.3.2, I believe, is still the current one. Were there any other things you wanted to call out, Stephen?
No, those are the main ones. Work continues on a variety of things. So the Canon piece is the most important, and we really hope to get it merged this week, and that'll open the gates for a series of PRs that will follow. Credo is also getting a number of updates as it goes along. There's also a new Credo-based DITCOM mediator that's getting very close with a number of improvements for for scalability, improving scalability and robustness. So things keep moving along on those fronts.
Awesome. Cool. That's great to hear. let's see, any other project updates or general announcements that anybody has? All right, let's see. With that, I will go ahead and let go of the screen share and pass it over to you, Tim. Thank you so much.
Awesome. Thank you. Hi, everyone. I definitely don't have an hour's worth of content, so I'm hoping we feel free to interrupt me, ask questions as we go. Don't feel like you have to wait to the end. Sorry, I'm just rearranging my windows here. Cool. Yeah, so my name is Tim Cappalli. I'm a standards architect at Okta, and I'm also an editor of the Digital Credentials API, so that's why I'm here to talk to you today. So I wanted to give you a quick update, some background, why, where this work came from, why it's important, the layering and the components, which is unfortunately a little bit confusing, just because, as you all know, it's a fairly complex ecosystem. Go over a high level shape of the API, and then I'll give you some status on the work itself, the standardization process and the ecosystem support. So background and design goals. I assume you can see my screen because nobody is saying you can't. So I'm gonna keep going.
Looks great.
Cool. So the problem, I'm sure everyone's familiar with this. Sorry, we're using a couple of slides for background here, but generation one of the problem, holding an identity document up to a camera, doing a selfie match, all these things, really bad user experience. Users don't like it, not secure, and there's no cryptographic verification. So that's great. A lot of work went into building out the verifiable digital credentials ecosystem. And then we hit generation 2 of the problem, which is now we're relying on kind of browser primitives and other ecosystem primitives such as custom schemes and QR codes, both of which have very poor security properties and also result in a very bad experience for users, which puts any new technology at risk, right? If users don't like it because of UX, that is often a reason users will rebel against it, which we have learned firsthand from some of the early passkey experiences. So what are custom schemes and what are in the wild? This is a few examples, right? So it's the idea that you can just use essentially a protocol identifier and then pass a bunch of data behind it, similar to URL. So these are not standardized at all. It's funny. There was a lot of assumptions early in this work that these were standardized. There's actually no standard for custom schemes. There's a standard for URIs, but not custom schemes, which are a more opinionated implementation of URIs. So the core challenges with custom schemes in this context, they can be invoked from an insecure context. And from the web platform standpoint, that's essentially running over HTTP, or there's some TLS issue in the browser, like a certificate error, right? Those would be considered insecure contexts, which is problematic, right? If you've kind of secured everything else, but then the user's presenting or getting issued over, a plain text channel, not great. You can actually do on-device phishing via app selection, right? So we typically think about phishing in the context of, a website and a remote attack, but you can actually do this on device by, tricking the user into opening an app they didn't intend, which for a presentation, right, there's other protections that can go into play, but for issuance, right, you can end up issuing into a wallet the user wasn't expecting, and there's all kinds of attacks that can happen just from app selection. This is in this example, this is not actually how it looks on Android, but if you're familiar, it's a list instead of a horizontal icon library. This is illustrative, but you'll notice either way, there's no requester or origin identity, right? Where did this request come from? This thing just popped up from my OS. I have no context. And as I mentioned before, it's not standardized and not guaranteed. So one of the challenges with it not being standardized is the implementation is completely different on every platform. So on Android, for example, you get it's called the Android disambiguation UI, which is essentially any app that has said it can work with this custom scheme will show up in a selection screen. Not super valuable to a user. This is incredibly confusing. And on iOS, it's even worse. On iOS, the most recently installed app that was installed by the user that claimed that custom scheme gets it, and there's no selection, right? So really, really bad, as I'm sure you can take away from this. Two other ones. There's a context switch during the app launch. So assuming I was on the selection screen and I clicked on one of these, I get completely taken away to another context, another app, and I have no predictable way to get back to the caller, right? Be it a website or an app. That's really confusing for users, right? Even there's a lot of experiences today that when you hit the back back swipe or on iOS at the top left, right? Like you just you get stuck, right? Either you go to the wrong app, you go back to the home screen, you end up back at the correct app, but there's no state transfer, so like the app gets in a weird state. Not great. And the last one, which is kind of a result of all of this, is there's also no graceful fallback if there's an error. For the same reason, you can't get, always back to the same app. If something goes wrong, the user can't kind of self-remediate. And once they find their way back to your app or website, you essentially have to trigger the entire flow again. And from a UX standpoint, right, as I mentioned, right, this is just not, users don't understand even what a credential manager or wallet is. They don't understand why they need it. And it, they don't understand which one to select because it's not a common concept quite yet. We learned a lot from passkeys, right? There's actually a ton of parallels between the VDC ecosystem and passkeys and WebAuthn. And what we learned from a lot of UX research and the FIDO Alliance is like users think about accounts and credentials, not authenticators, right? So authenticator is kind of the loose equivalent to a wallet in the VDC ecosystem. They're all kind of collectively called credential managers. Caller context is really key, right? When a user is signing in with a passkey, they would like to get confirmation that like the request is they want to be able to correlate the thing they were just on to the request that just popped up from their device, right? So seeing in this example, login.example.com reaffirms that this was kind of the right thing to be doing. And if you do not have a credential that you need on your local device, we need a way to get it from another device, such as your phone, and it needs to be secure, easy, and resistant efficient. This is a example, and I know this is a very extreme example. This is my test phone. I have tons of wallets installed, but this is an example on an issuance flow. So I showed an example before for presentation. There's no way a user would be able to reason about this, even if there's only 3 options in this list. This also doesn't guarantee that once you get to the wallet, that wallet is even compatible, right? So with protocols, other pieces of the ecosystem, right? So these are just really, really poor experiences. So some of the design principles that went into the Digital Credentials API to solve some of these challenges. 4 big ones: separating the act of requesting from the specific protocol, which allows flexibility in the protocol and credential formats, right? So the API, the Digital Credentials API, does not define any protocols or credential formats. That was a day 1 goal, which is slightly different if you're familiar with WebAuthn, right? WebAuthn kind of has everything in one spec. The web platform API, how you talk to an authenticator, the credential itself and the format, what a relying party is supposed to do, that is very different. Like these are on opposite ends of the spectrum in terms of these spec contents, right? This spec exclusively defines how to use, make a request for presentation or issuance from the web layer in JavaScript. And the reason for that, right, is we don't want browsers and the web platform to hinder progress or new developments, right? If someone has a new protocol, transport protocol, right, for presentation or issuance, that is better. At a minimum, right, you don't want people to not be able to even test with those new protocols. And it certainly shouldn't be opinionated about credential formats, which is another layer removed from all this. Require request transparency, right? So enable the user agent, right? The browser is the user agent. The browser is ultimately responsible for helping the user reason about things that happen. And so the user agent should, if it would like to, be able to help the user understand a request. Now, that doesn't mean like you're going to show the entire contents of the request, but you may want to put up a interstitial if this is an MDoc MDL-based request and you're requesting every single attribute on that, and you are a advertising site, for example, right? These are just raw examples, but the user agent is, as I mentioned, the users trust their browser, and the browser needs to be able to at least help the user reason about things if needed. You can think of it similar to like safe browsing in Chrome, right? Like there will be a point where like there will be known verifiers that have abused, or they're taking your information and feeding it somewhere else, right? These lists will come about over time. And a user agent needs to be able to at least help the user understand that if they continue, certain guarantees may not be met. But on the flip side of this, the API assumes response opacity, right? So is always assuming encrypted responses, regardless of whether the response is encrypted. right? And so that allows verifiers and holders to control where PII is exposed. So, you know, most of the kind of recommended practices today say to encrypt the response, and this API assumes that is the case. The last one, super important from a tracking standpoint, and this is very similar to what we have in WebAuthn as well. Prevent the website from like being able to silently query for the availability of a credential, and not allowing a website to talk to a credential manager on the device without the user doing something first, right? The user has to be in the middle. There has to be mediation either from the OS or the browser before the web can talk to the app platform, which is a fairly standard practice across web platform APIs. Just getting any hands up. Okay. Components and layering. This is, as I mentioned, the most complicated part of this. And as you all know, working in other parts of this ecosystem, it's complicated. The one important thing, as I mentioned before, I just want to reiterate, the API itself is protocol and credential format agnostic, right? So it simply says, you know, the restriction is essentially, if you want to use this API, you need to define a protocol identifier that can be passed in the protocol field when you call the API. Right? That's essentially where the line gets drawn. So today, the three major protocols that are used over this API are in the OpenID world, OpenID for VP for presentations, OpenID for VCI for issuance, and then ISO 18013-7 Annex C, which is essentially an MDOC only presentation protocol. And as you can see, as we go to the right, again, the API doesn't care about credential formats because that's the exchange protocol's responsibility, for lack of a better term. This also means, again, you could prototype your own API, your own exchange protocol and play around with it and you know, try new things, which is great. Roles and responsibilities. This is probably the most important slide at this deck, and we'll share the deck. Three major components, right? The browser, which is the web platform, the OS platform, which is the app platform, and then the credential manager itself, which is typically in this VDC ecosystem called a wallet. The first set here, right, is we wanted to differentiate between permission and consent. You know, the working group, you know, had a very principled position that this API was only responsible for capturing permission, and capture is even a strong word because you don't typically capture permission, but the user has to grant permission to continue with this API. It is the credential manager's responsibility for capturing consent, and that is fairly uniform across the board from a legal standpoint as well. Not a lawyer, but that's what I've been told. So a combination of the browser and the OS platform, it might be one, it might be both. It's ultimately up to the browser and the OS vendor how much friction they'd like to add, but they would need to capture permission, get users permission to continue on and pass this request to the underlying framework to get to the credential manager. If we look at the browser specific responsibilities, right, the API surface itself, right, it's a JavaScript API, is ultimately the browser's responsibility and role to accept requests to that API and provide responses back. Basic request validation. And I don't want to scare anyone, but the browser does need to at least check basic things like for example, the API requires a JSON serializable you know, string. That's things that the browser will have to do. But beyond that, it's, you know, most browsers are not intending to understand the protocol itself. Now, again, it is the browser's right to do that if they choose, right? There are some browsers that may validate the internal structure of a request deeper than the DC API top level parameters. But, you know, that is not required from the API. As I mentioned, secure context is really important, right? Like you are in a TLS session with a valid certificate. Check, that is the minimum bar for calling this API, with the exception of like developer cases where you're using localhost, which has its own set of restrictions that would prevent abuse. And the browser is ultimately responsible for interacting southbound into the OS platform, right? Those are typically OS provided APIs. If we move over to the OS platform now, the OS platform is responsible for providing a credential selector for presentation or a credential manager selector for issuance, right? And that's the big difference, right? This, as I mentioned earlier, the UX research for passkeys and, you know, early on in the VDC days, users users can't be expected to understand where they stored this thing that they got potentially a year ago, 2 years ago, right? So credentials, it's important to provide the credential context for presentation. And then ultimately you do have to ask the user where they want to save a credential for issuance. But that should be a little bit more robust and not just show every single option if those options cannot satisfy the request at its most basic form. The OS platform is also responsible for cross-device transport, right? How do I actually get a request from my laptop to my phone securely, phishing resistant, and in a user with a good user experience? And then the OS platform is also responsible for native apps that use the Digital Credentials API as well. And I'll touch on that a little bit more, but ultimately there are just as many native apps that need to do an age verification or request a diploma inside of the native app context without breaking out to the web as there are websites. And the last one, this group, obviously, this is probably where you're most familiar, the credential manager side, right? Holder consent, verification, the issuance and presentation protocols themselves need to be implemented by the wallet, key management, all of the things that come along with being a manager of credentials, right? Is still that responsibility. So this seems to have been resonating. We've been using this slide for a while because this was one of the hardest things to understand is who's involved and what explicitly is out of scope for that party. All right. Diagrams, these are always helpful. And at the link below, they'll take you to a website that has these. This is a way to expand on the previous slide and really talk about the different API services here. So as I mentioned, the browser is responsible for the Digital Credentials API itself, the W3C JavaScript API. And then the browser, I hope you can see my mouse. The browser is responsible for getting the request south, downstream into the operating system, right? And so this API set that the browser implements is typically platform specific because it runs in platform native APIs in the, language that the platform uses, right? So an OS platform would provide this. On Android, it's actually the exact same credential management API that exists on the web, which is great. On iOS, it's a little, and Mac OS is a little bit more of an opinionated, Swift style API. For the verifier in a native app, again, like whether it's an issuer or a verifier, people interact with native apps just as much as the web. Essentially, there's an OS version of the Digital Credentials API that is used for native apps. If you're familiar with WebAuthn and passkeys, it's the same thing, right? We have the W3C WebAuthn API that is responsible for the web experience, and then the platforms implement essentially, with a small caveat, an identical API that native apps can call using native code. And so it's the same thing here. Again, on Android, it is literally the same API as you call on the web. You can pass the same inputs. On iOS, iOS is a little more complicated. They have their own API with a different name. I don't know. I can only speculate on reasons, so I won't. But there's a slightly different one, but with the same result of verifying, getting a verification in a presentation. And then to talk to a credential manager, right? So if you're implementing a wallet, there is a set of APIs that the wallets need to implement to then talk downstream into the platform to help all, to bring this full circle and kind of have the plumbing reach A to Z. So the OS again provides a credential management API specifically for credential managers to implement, which allows you to receive a request and then send back a response through that plumbing. Now, if you look at cross-device, looks very similar, except we chopped a third of it off. So on the local device where you're, trying to satisfy a issuance or presentation request, same thing, everything looks exactly the same. The big difference now is that if the credential manager is on my phone, there's a break in these, two diagrams, and there's a protocol introduced between those devices to handle getting that request and response securely between those devices in a more phishing resistant manner and providing a good UX. So that is actually a FIDO protocol that we use with passkeys. So if you've done a cross-device flow with using a passkey, right? Very common if you're on someone else's device and you need to quickly sign into something, right? All your passkeys are not typically on their device. It's typically used for those exception cases. We essentially made one small change to that protocol in version 2.2. Which allows essentially carrying the Digital Credentials API payload. And now you get all of the great benefits and pretty nice UX to handle the cross-device flow. And so on the what we call the nearby device, where the credential manager is, the only thing being implemented there is the credential manager API for the wallet itself, which you would implement the same way if you were locally on the device. So that's what's really important, right? No credential managers have to worry about implementing the cross-device protocols. Browsers don't have to worry about that, with one small caveat I'll talk about in a second. And issuers and verifiers absolutely never have to worry about these transports, which is beautiful. The only people who have to worry about it are the OS vendors. And again, it's already implemented at scale for passkeys and used heavily. The one caveat, as I mentioned, there will be cases where the underlying operating system doesn't yet support it, right? Good example, Windows 10, which is still out there in mass and is not getting updates anymore. The browser can effectively implement that on behalf of the platform to expand the reach of the protocol. The other example is on Linux. Any Chromium-based browser implements this natively for you on Linux as well. But the intent is that it's implemented by the platform. When we we're kind of generically saying this is the pattern that you're using. You're calling this purpose-built API to do your thing. When we more explicit and say W3C Digital Credentials API, we're typically referring to only the web platform piece. This isn't a super important detail, but I just wanted to call it out because people do tend to use it kind of lax. So we've been trying to get better about, if we are explicitly talking about the web API, we throw W3C in front of it. All right, I don't see any comments or questions, so I'm gonna keep going. Again, feel free to stop me. The API itself is very simple. As I mentioned, this API does not define any of the protocol or credential format stuff. So it is very simple. It takes two inputs, a protocol identifier, which is a string, and a JSON serialized data parameter, which is the request itself. And you can have multiple requests. The reason for supporting multiple request types is, for example, Apple has chosen to only implement ISO 18013-7 Annex C. The rest of the ecosystem has largely standardized around OpenID for VP. So you don't want to have buttons that say, if you have an iPhone, click this button, everyone else click this button. So what you can do is you can send both of those requests. Through in the same, two different request types in the same input request. Sorry, too much requests. So that allows you to avoid that challenge, which is great. And then once you send this request, as I mentioned, the browser may show some friction. There's a default prompt in Chrome today. That is likely to get more intelligent over time. But in the spirit of this being new, there's one generic prompt that says, I can't remember the text because it just changed, but something like, this is going to try to talk to your wallet. Are you sure you want to continue with the request? Once the user clicks yes inside of the browser, they'll typically see this OS selector that's shown on the screen, and the user can decide to agree and continue, select a different credential, and then after that, the request goes to the credential manager. The important thing, and I don't have a slide for this, the important thing here is this is the permission prompt, right? So this is the OS's permission prompt, effectively. The wallet, in both cases, iOS and Android, at this point, the wallet has not learned about this request yet. So each platform has different ways of handling this. But at this screen where the user has to make a selection, the wallet has not learned anything. But the wallet is able to provide context to the OS to provide this rich selection screen. Now on Android, so I will go into detail because we do have some time. Okay, so on Android, essentially, you as a credential manager write what's called a matcher. The matcher is dynamic WASM code that as you add new credentials to the credential manager, you rewrite this WASM code and publish it to the OS. The OS runs a matcher in a sandbox, right? So no network access. All it does is feed into this selection screen, which is really great for privacy because you can't get an inbound request and then report off to some back channel server that the user is getting a request, because even the context from the request could be privacy invasive, right? So very, very restricted. All it is there to do is support the selection screen. But it is code that is owned by the wallet, published to the operating system. On iOS, they take a different approach, similar to passkeys. As a wallet, you have to publish a limited set of metadata to the OS in a selection, essentially a credential manager selection store, which then populates the selection screen. Now, after the user clicks agree and continue, the entire request gets handed off to the wallet credential manager. And at that point, the credential manager can do whatever it wants. It can just show a bio prompt. It can do nothing. Most people are going to show a richer consent screen. That's where you can show a privacy policy. You can show an icon. You can show a trust framework. You can show a check mark. But you are in full control as the credential manager after the user clicks agree and continue. So that's the gate between permission and consent. To kind of loop back on some of the problems we were trying to solve, right? So in that example, we saw who is asking now. These are two different examples. Oh, no, it is the same example. Okay. Who is asking, right? In this case, verify.example.com. If it was a native app, it would show the app's name. We can see that it's credential centric, right? It's not even mentioning really the wallet or the credential manager. You can optionally, as a wallet, put your wallet's name. In this case, it would be where Utopia DMV is. It's your choice. But the point is the user doesn't have to remember where they stored this thing that can satisfy the request. It has a selector, right? So in this case, I actually have two MDocs that can satisfy the request. I can swipe between them, and you'll see what they're asking for at the highest level, right? So that is something you put into the request. And, again, you'll probably show a richer version of this in the actual consent dialog that the wallet renders. So we've solved a ton of those problems that I mentioned at the beginning, even just with the credential selector. All right, let me pause there because I see this question. Does this support digital credential exchange between two native apps on the same device? Yes. So the native app equivalent you can call, and the platform handles getting it to essentially the native credential manager app. Exactly. There, the flows are on Android. The flows are identical. iOS, again, there's the verify with, it's a branded API. Like verify with Apple Wallet or something. API is slightly different than the web API. Okay. So issuance, very similar, right? You pass in a protocol string and you pass in a request. The one difference, sorry, I probably should have had a slide for this, but the one key difference between issuance and presentation with this API is for presentation, it's expected that the response goes back through the channel, right? You resolve the promise. Issuance, there's a lot of stuff that happens in the wallet that doesn't require communication back to the issuer website in the front channel. So presentation, you're expected to send the entire verifiable presentation back. For issuance, you generally just send an ACK back, like, yep, a wallet was selected and it got it. And that's, again, in your control as the protocol of what you want to send back. But generally, you just want to be able to show something on the issuer website, like, yep, continue in your wallet. That's just a big difference in the expectations of get versus create. So I just wanted to highlight that. And you'll see a very similar thing. Unfortunately, I didn't have two wallets that supported issuance yet. Issuance is a little bit behind on presentation. Presentation has shipped in Chrome on all platforms and in all Apple platforms, OS 26 and higher. But issuance is a little bit further behind. It's close. So I didn't have a better example with two, but you can imagine the same selector screen to pick where I wanted to save this. So once I click continue here again, it hands it off to the wallet. And away you go. All right, bunch of questions came in after that. Leaving aside the wallet selection, UX, and navigation issues, can WebAuthn and the origin binding alleviate some OIDC security issues that DC? I think I would need you to expand on that because that's a fairly deep question. I'm going to answer the next one and then maybe you can come off mute. For cross-device, wallet app browser verification, who is responsible to send the presentation to the verifier? So all cross-device does is get the object from device B back to device A. Device A, the operating system, sends the response back through the digital credentials API, resolves the promise. And then your website front end is responsible for getting that to your back end, just like anything else. So it's only handling the plumbing between the devices at essentially think of it as the OS layer between the devices.
Thanks. And in case not cross device, sorry about that. case it's all handled in the mobile?
Yeah, so it's the same thing, right? So if the OS APIs are just responsible for getting, it's just the plumbing, right? So what you do as the native app with that, you need to either validate it in your app or send it back channel to your backend service. One thing we are trying to do so we're working on a VDC architecture document in IETF. One thing we're trying to clearly define in roles there is the difference between a verifier and a verifier service and an issuer and an issuance
Cool.
service
Yeah.
because of some of these challenges describing that. Yeah.
Thank you.
All right, Nikos, do you want to come off mute and expand on that a bit?
Yeah, sure. Well, obviously, we do have this OpenID for VP only flow that provides both authentication and the presentation flow when the wall interacts with the verifiers. But there was recently a paper from a white paper from the FIDO Alliance that suggests an alternative approach where WebAuthn passkey could be used to authenticate the wallet towards the verifier and leverage, these origin binding methods that on all these goodies that the WebAuthn provides. And I was wondering if this approach could help to solve some of the things that also DCAPI tries to solve. Especially
So that white paper, yeah, sorry. Yeah.
Especially in case of cross devices, flows, session fixation, things like that.
Yeah, so that white paper was really talking about, I worked on that one. It was really talking about how to use FIDO and WebAuthn to secure kind of the wallet itself, right? Either through the issuance process or getting into the wallet, right? So be it a web-based wallet where the user getting into the wallet itself, like WW Wallet, for example, is really, I mean, it primarily uses passkeys to secure access to the wallet on the web. And that same pattern can be used to access a wallet, a native app, right? You use a passkey to get in. And you can also then use passkeys in the wallet to communicate to the issuer, to authenticate to the issuer. But I don't think it talks anything about, there shouldn't be any relationship to the verifier because it's actually, it's a one-to-many, not a one-to-one relationship.
Okay, I maybe have to recheck. Thank you.
Okay. But just to the whole goal with this work was to do what we did for FIDO and WebAuthn for digital credentials. So like the relationship is that like this stack of APIs is the equivalent for this ecosystem, right? So that's why we're just reusing the protocol with some changes for cross device. The API itself hangs off of Credential Manager, which is the same place WebAuthn is. There is certainly interesting overlap in using passkeys to authenticate and do certain things, but the APIs themselves are fairly specific.
Okay, thank you.
All right, just quick status. If you are curious about the history of this, I just have a little slide here, right? So like we started this work in 2021, which is crazy. It feels like forever ago. Really looking at like finding gaps in the VDC ecosystem, especially around UX and authentication, where FIDO has traditionally provided a lot of value and guidance. Went to IAW, started talking about like what would it look like to have an API. Lots and lots of debates. I think many of you were there. And then we went into the WISIG at W3C, which is essentially an incubation group where you get IPR protection. It's like a place for people to meet and come up with essentially draft specs. You can't write your own spec, with the goal of eventually moving to a working group. Around 2023, OpenID folks started to collaborate around the protocols because at the end of the day, while the DC API is protocol agnostic, the protocols themselves need to have a carve out in the spec for how it operates over the DC API. So for example, OpenID for VP was very, very heavily influenced by OAuth and OpenID, which are redirect based and have all these like response modes and all these things, which like you don't need in a JavaScript API, right? It's like in and out. So there is, for example, an IP which says, here's how you use this protocol over the DC API, and here's where we define the protocol string to use. So that's kind of when that started. And then earlier this year, we finally got a working group going. Instead of creating a new working group, we joined with the FedCM work, which is a federation web platform API, for two reasons. One, there are some similarities there, and well, three reasons. The group is already up and had a chair and had good infrastructure, and three, a lot of the same people are involved in both initiatives. So that is how we ended up in that working group. The status itself, so we published a first public working draft July 1st, which was really important because we needed a stable link for things like OpenID for VP to reference. It was kind of a WISIG GitHub.io kind of link, which is not great. And also we needed the ability for regulations and architecture reference documents to be able to reference it. We are working towards candidate recommendation. I can't say when I think that's going to happen. I'm hoping we can get very close by the end of this year, but it's already October, so I'm hoping for early next year at the latest. And as someone already threw in the chat, the CTAP change in FIDO was already done earlier this year. Finished that in January, and it's already implemented in some capacity on all platforms. Cool. Current major work items left, right? Like again, I think these are what I would call the blockers to getting to CR right now. The current version of the spec has a lot of text around having a protocol registry, right? And the goal with that was because one of the complications of this architecture is that the protocols themselves are not defined in W3C, but a W3C API that exposes access to these protocols lends the W3C to having opinions about the security and privacy properties of those protocols. So like there's a security review group, there's an architecture group, there's a privacy group. And so like how do they express concerns, request changes when that work's not being done here? So one of the areas was like having a registry that's not necessarily restrictive, but it would say like these are the protocols that are out there that are listed in the spec that have gone through some type of blessing by W3C. The challenge with that is then it turned into like, well, if as an implementer of the API, you don't actually have to support all of these or you choose to support others, what's the point of the registry? So we are now at the point where like I have a PR written to take the registry out and it's kind of just waiting there for discussion. In Geneva, there was a lot of good conversation around, registries are actually problematic for many reasons. So there's a lot of conversation around that. If you have feedback, anyone, just a note on W3C, you have to be a member and in the working group to join calls and do PRs, but you can comment on issues that are public GitHub repos. So if you have opinions on the registry, I will at the end of this grab the link and you can throw some comments on there. There's about 19 issues related to registry in the GitHub repo. So there's like kind of one superset issue where we're trying to gather feedback. You can also comment on the PR, but like my proposal is to remove the registry at this point in time. It could be added at a later date if it's needed. But that's obviously, there's not consensus on that as of right now. So that's a big topic. Right after this call, actually, we'll be talking about it again. Adding a testing framework. So for example, in WebAuthn, we have a WebDriver-based implementation of WebAuthn that can allow you to do some automated testing. Really important here because the ecosystem is even more complicated. So that is, that there's a PR written for that. That's getting a lot of feedback. And the last one is a new issue that has been brought up. It's not necessarily unique to the Digital Credentials API, but it's a little bit more visible, which is the API itself can't really right now prevent a user from essentially accepting the request into a malicious wallet, and that malicious wallet forwards it on to a good wallet, which is the expected wallet of the issuer, right? So there's no binding of the request itself to the first selected credential manager. And that's a fairly complicated problem to solve. So I'll give you a real example with named examples. I sideload on a wallet called Google Wallet, but it's not actually Google Wallet. And a request comes in, the user selects it, and that app just has code that posts the request to some attacker server. And that attacker then takes that request and invokes the real Google Wallet on a real device that would pass all of the issuer attestation, client-based attestation that is required by that issuer. And away they go because that response doesn't have to go through the front channel. the caller, the calling context loses sightline into that request after that point. So that's problematic, right? That's a problem. And so we are trying to see if there's ways we could make some API changes to help allow like the platform to help here. One example, and it's not a one-to-one, but in WebAuthn, we have this thing called client data, and it's the opportunity for the client where the API is being called to inject a bunch of data, sorry, obviously, that like around like what type of request is it, like reaffirming the origin that was detected by the platform. So there may be an opportunity to do something similar and find a way to mandate that be sent back in the response to the issuer, for example, through the front channel. So there is an issue for that as well. At the end, I will drop that into the chat if you have some technical thoughts on how to solve that. Some folks at Google have 4 proposals. They're all not great, and they admitted that, right? This is a pretty hard problem to solve. But that is another area that will probably add a little bit of delay to getting to CR, because we do want to solve that. Ecosystem status, and then I'll wrap up. So pretty decent support because this is implemented in Chromium. Essentially, every Chromium browser, unless they've explicitly removed it, which is, I believe, the case with Brave, has this by default. And presentation has shipped as of Chrome 141, which I believe dropped today. And issuance is in Chromium-based builds, but behind a flag for developer testing. So you have to enable that. Firefox, unfortunately, does not have support except for iOS, because no browser on iOS is actually the browser. It's WebKit with some small caveats. And then Safari has released support for presentation with a limited set of protocol ISO 18013-7 Annex C, with a limited set of doc types. So all these caveats, I'll give you the link to this page in a second. But we are at least seeing this technology is now usable across a large number of devices, which is great. This page is from digitalcredentials.dev and is updated weekly, assuming there are changes. So definitely keep an eye on that. There's also on that, essentially digitalcredentials.dev, click on ecosystem support. There's also a second tab on that page that shows you like the true end-to-end with all the combinations, right? Because as I mentioned, the protocol layering is very confusing. It can be confusing. So there's a page that actually explains the difference between a request that comes in. Does the OS support that protocol? Because, for example, as I mentioned, like Apple platforms are only supporting 18.13-5 and 7. So like what happens? Can that request get to a credential manager? What if the credential manager is on the device? So there's a pretty exhaustive list of like the most common platforms, operating systems, and devices and credential managers, and shows kind of what a request get through all the way. So long story short, keep an eye on digitalcredentials.dev. It is a community resource. So we actually have a W3C community group that is spun up but has not started a meeting that will effectively own the content. Right now, it's just a bunch of contributors. If there are any topics on there that say coming soon, that means no one has started writing it yet. And if you would like to contribute, please reach out, or just look for any of the open issues on the GitHub and feel free to just start going and do a PR. We would love some more community support on getting that up and running. It gets a ton of traffic already. So we'd like to get that content filled out soon. All right. Still have 10 more minutes. I promised some links, so let me do that while we're waiting. And if there's any other questions.
Let's see,
Here's
Nikos, it looks like you've got your hand up. Oh, thanks for those links, Tim.
Yeah,
What
that's
was
me
the second?
again.
Sorry,
Quick
real quick
question.
before I go, I said I was going to give a link to the registry. Or what was the other one? Yes, I got it. Sorry. Go ahead. Go ahead, Nikos.
Yeah. Well, most probably this is not a new discussion topic, or even not a showstopper, but it's about the overlapping roles between wallets, platforms, browsers, etc. And you mentioned previously that the goal, and I fully agree with that, the goal is to decouple, let's say, the permission from the consent. However, the fact here is that in many cases, the ecosystems, the wallet ecosystems, comes along with a trust model which usually mandates a lot of checks, both in terms of consent, or in terms of permissions, eligibility of the verifiers, eligibility of issuers. So I wonder how exactly, what would be the best practice to, to work around these overlapping processes that runs both in the platform and the browser, but also might be necessary within the wallet app.
Yeah. I don't think I'll go back to the slide real quick. I don't think we're not necessarily saying that because the browser and the OS are responsible for permission that you also can't do permission in the wallet if you have a different type of permission or different reason. We're just saying that like the browser and the OS platform have no interest, or we don't believe there's even a need for the browser or the OS platform to do consent, right? Because it's not in control of the credential. This isn't, it's meant, I guess it's kind of like a one-way street. Like we're not going to go backwards and say that the browser and the OS have to do consent, but if you also want to capture something that was done by another party, like you certainly can. And I think a lot of that is down to over time, I think where this will go is, are there optimizations over time that can be taken to optimize the UX, right? Because even the selector screen versus the wallet selector screen, right now they're, it's very similar prompt. Maybe that second screen can be optimized so that the biometric prompt is part of that and you don't have to do a separate call, right? So I think that will come in time with UX and deployment guidance. But again, like I don't think anyone's saying like, if you have a different reason to request permission in your, once the request gets handed to the wallet, like it is expected that once the request goes to the wallet, you are in full control and can do whatever you want within reason, depending on other policies and things. But does that make sense?
Yeah, just one minor clarification. By saying permission here, we also are referring to the permission of the relaying party of the verifier, if the verifier should be able to ask the specific claims. Isn't this part of a trust model too? Isn't this something that the wallet should be able to handle too? In maybe some case, there is a mandate for the wallet to check this type of eligibility. For instance, yeah.
I mean, the permission at the browser and OS layer is simply it's to prevent, like, for lack of a better term, layering violations, right? Like this request is coming from the web and now going to the OS. Are you okay with that? Right? Like, because if you think about a WebAuthn flow, right, there's a very clear dialogue that pops, a blocking dialogue where the user has to make a selection before you can talk to a credential manager, for example. So that is the only intent of that. And like on Safari, I don't believe there is one, as one example, right? Chrome has decided to err on the side of caution. It's easier to remove it later than to keep to add it because it's a change in UX. And so, there may be cases. I think Chrome has publicly talked about like thinking about this like as a risk score, right? Like again, like safe browsing, right? Like there may be reported abuse of a site. Maybe there's a scarier warning, but I don't quote me on this, but I can point you to Chrome's opinion on this. My recollection is that their intention is to never completely block. Their intention is to provide the user context and allow them to continue if they choose. So.
Okay, thank you.
Jim?
Thanks. Excellent presentation. Appreciate that. The question I had is scenarios. So I've worked in digital identity for a while on some projects, technology solutions and all that. And the one thing that is sort of a focus on my area of concentration now is I'll call it decentralized environments that are very different than static. So like I did the Rhode Island digital identity project, but that's a normal digital identity project that has all kinds of assumptions about the availability of resources and stuff. When you look at what I call field operations, it's a completely different world. So you don't have access to things like the internet on a reliable basis. And I don't know, because you're involved in a fair amount of groups, if the groups are actually looking at those more complex and challenging environments when they're trying to lay out strategies and architectures for solutions.
Yeah, I think the groups that typically look at that are what I would call like for lack of a better term, the overlay groups. Like, so FIDO obviously is responsible for the FIDO protocol used for cross-device and other things, but like FIDO is also it's not only an SDO, it's an industry org. So a lot of conversations happen there around like the actual feasibility of these use cases. That's why some of the UX work happens there, because you can bring in, it's one of the few places where like all the platforms come, all the browsers come to solve like not necessarily the technical issue, but the business or UX or developer problems. So I think yes, maybe not in the most structured or like even I'll say transparent sometimes way, but I do think those conversations are happening. If you have feedback on how to bridge some of those gaps, I'm all ears, because that's always, one thing that's been clear from this effort is like there's so much work going on in so many different places that any improvement there would be beneficial. The nice thing too is in W3C you can spin up community groups really easy, and you don't have to be a W3C member to join. So regardless of whether it's a purely web platform topic, you can have a safe space, for lack of a better term, to have those conversations. So I know it's a
Thanks.
Did we lose you, Tim? Can you hear us?
Yeah, thanks.
Let's see. Uh-oh, I think you might have been dropped from the call. Let's see. Or is that just me?
No, he's
No,
gone.
it's not.
He's
He
gone.
seems to be frozen. Yeah, thanks, Ramek. We can give him a minute. We still got a couple minutes left. Jorge, you had a question. We can ask it again when he walks on the room. There he is. Tim's back.
Are you back, Tim?
Sorry, that was weird. Zoom just quit. Like, so just bad Zoom day. I'm not sure how much of that you heard, but the TLDR version was a lot of those like business and use casey conversations have been, especially on this topic, have been happening in, well, the verifiable digital credential space, I should say, have been happening in FIDO and across W3C and OpenID. But the nice thing about W3C is regardless of whether you want to work on an API, like a web platform API, you can still spin up community groups where anyone is invited. Because for better or worse, FIDO unfortunately had to be a member to be part of most of the conversations, which, is why there are more folks that are part of those conversations. Some people like that, some people don't. So yeah, I think OpenID is also another place to really tackle some of those, not necessarily non-technical, but less technical problems. And Jorge, I can stay for like 1 or 2 more minutes if you want to do one more.
Tim, I have my
Yeah.
question on the selection screen. You said for remote verification, the selection screen displays the website domain.
Yeah.
For the verifier.
Correct.
What's your take? Like, I think for a lot of users, maybe a website domain might not be sufficient information to know whether to trust that verifier.
Yeah.
Are there any plans to introduce additional context descriptors that could provide better information to the holder? What organization is actually behind that request?
Yeah, so I think when you get into needing that, which I agree, it's a really important thing. That's really where like signed requests come into play, and like the wallet screen that pops up can show that additional context. The first selector, the permission prompt, is difficult because it's being rendered by the OS using context from the request and the platform. So it's hard to put free text things in that, because then it becomes untrustworthy, right? Like the origin is something that the web platform and the app platform have strong assurance that is where the request came from because of the layering in the trust model. Anything more than that is like trust me, bro, kind of thing, right? Like, so I think that's where what I've seen is most people are going to do signed requests for that purpose. So they can put in a additional context, put in a green check mark, put in other things that require verifier registration. So it's just a very hard problem to solve in that kind of gray box between the web and the wallet. If that makes sense.
Awesome.
On the last one on Nikos, I can take that real quick. Thinking about it, yes, for how does this work for PWAs? It's not a problem that's unique to the DC API, right? Like the same thing happens for WebAuthn. Unfortunately, like browser extensions, for example, well, you get asked to install a browser extension, it intercepts requests and all that. I think the interesting thing for PWAs is like the redirect flow actually works quite well because you're staying inside a web context. It's not perfect, but yes, it is top of mind. But like we had to get kind of like the platform plumbing takes a long time to percolate in the ecosystem. The web is much easier to update because you get a Chrome update, every 2 weeks or so. Let's collaborate on that once we get CR of 1.0 out. I think we will have a lot more time to start doing the PWA stuff. Yeah.
Awesome. Great. Thank you so much, Tim. Thanks for answering
Cool.
all those questions. And was there something else?
Oh no, I was just gonna say sorry for dropping with the Zoom issue.
Oh, no worries at all. Yeah, thank you so much for your time. It was great to dig into the DC API. I've added the link to the slides to the meeting page for those following along the recording. So thank you so much for the presentation and discussion. And thanks everyone for joining and participating. Join us next week to hear about OAuth and other protocols from Tim Bouma. So thank you so much. Have a great day. Have a great rest of your day, everybody. Thanks, Tim.
Thank
Have a
you
great
all.
day,
Bye
everybody.
bye.
Thank you. Bye.